All right, section 1.2. So in 1.2, we're going to introduce two new vocabulary words, the domain and the range of a function. And then we're going to look at each of those things in two different contexts in kind of an algebraic point of view, meaning the function will be given to you by its equation, and then a geometric point of view, where the function is given to you not by an equation, not in its standard form, but instead with a graph. So without further ado, maybe from the previous video, when we talk about functions, you have this picture in mind, this kind of flow chart, where we have this physical machine here, and there's a conveyor belt leading into this machine, and then another conveyor belt coming out of this machine. And the idea is we're going to take numbers, and we're going to put it into the machine and see which numbers come out, inputs and outputs. Well, something that I neglected to tell you is sometimes you'll have a machine that you can't just put any number into. Some numbers won't work. So for example, if I had the function, I don't know, f of x equals x plus 2 divided by x minus 1. Perfectly good function. I might be interested in putting, I don't know, the number 4 into this function. And so I'd have to figure out what comes out. I'd have to figure out what f of 4 is equal to. But because I have this equation, the standard form of the function is pretty easy. I just copy exactly what I see here, changing all the x's into 4's because my input is no longer the generic input of x, but instead this specific input, the number 4. So I'd get 4 plus 2 divided by 4 minus 1. I'd get 6 divided by 3. And since 6 divided by 3 is 2, I get this equation, meaning when I put 4 into the machine, 2 comes out. There'd be a 2 in my picture right here. Great. Nothing new so far, right? Well, look what happens when I naively try to put the number 1 into this function. That sounds easy enough. You just have to figure out the output by evaluating f of 1. You copy exactly what you see here, changing all the x's into 1's. I got 1 plus 2 divided by 1 minus 1. I got 3 divided by 0. I got, I don't know what I have, right? I'm dividing by 0. Maybe you recall that dividing by 0 is undefined in math. 3 divided by 0 is not equal to 0. 3 divided by 0 is undefined. In this analogy up here, if you put a 1 into this machine, nothing would come out. The machine would break if you want. 4 is a good input into this machine. 1 is a bad, in some sense, input into this machine. You might be interested in what inputs are good inputs and which ones are bad inputs. Well, that's where domain and range come into play. All the domain is the set of all the numbers that you can put into your machine. That's it. If you want to write it a little bit more carefully, the domain of a function is the set of inputs for which the machine has a defined output. So for example, 4 would be in the domain of this specific function because when I put 4 into the machine, another number, 2 in this case, comes out. But 1 would not be in the domain of the function because when I tried to put 1 into the machine, nothing came out. The function broke. I got an undefined output, however you want to think about it. That's all the domain is. You might be like, but wait, there's two vocabulary words. What's the range? Well, the range is just the output counterpart to the domain. In other words, since the domain are all of the possible inputs, the range is just all the possible outputs. If you want a little bit more concrete of a definition, the range of a function is just the set of all possible outputs of that function. So the domain are all of the inputs, the range are all of the outputs. 2 would be in the range of this function because it's possible to get a 2 out of this machine. Really? How? You just put a 4 in, as the flowchart demonstrates. When we talk about domain and range in its simplest terms, it's just the set of inputs and the set of outputs for a given function. But that kind of begs the question of what can cause an undefined output in math, right? The reason 1 doesn't have an output associated with it is because of the nature of this very function, a 1 causes me to divide by 0. Dividing by 0 is bad in math. But is that the only thing that's bad in math? What else can't we do in math? What else leads to an undefined output? In other words, what else do I have to look for if I'm trying to exclude a number from the domain of a function? Well, the first thing, as we already saw, is you can't divide by 0. Period. You can never divide by 0 in math. So if you have a function that causes you to divide by some quantity, and that quantity can change, you have to figure out what inputs will cause that quantity to be equal to 0, 1 in this specific case. But unfortunately, that's not the only thing that can go wrong in math. In fact, the list of things that can go wrong, loosely speaking, in math is pretty long. But I got some good news. In our class, it's not that long. In fact, at this point in the class, our list only has 2 things on it. You have to make sure you don't divide by 0, and you have to make sure that you don't take the square root of a negative number. Okay, 2 comments here. First off, I'm lying to you a little bit. 1 can take a square root of a negative number. You may have seen it in a previous class. You may have gotten into complex numbers and be familiar with imaginary units. The square root of negative 4 is defined to be 2i. If that means anything to you, great. But for the purposes of our class, we're not dealing with complex numbers. We're only dealing with real numbers. And when our functions only deal with real numbers, we can't take the square root of a negative number. And so since our class will always deal with real numbers, in our class, you can't take the square root of a negative number. And you might note that I put a little asterisk right here. I'm still kind of lying to you. It's not just the square root of a negative number that you can't take in our class. It's any even root. So for example, if I asked you what the fourth root of, I don't know, negative 16 were equal to, that would be undefined also. Or the sixth root of some negative number, or the eighth root, or the 10th root, or whatever. Any even root of a negative number is undefined for the purposes of our class. However, rarely in our class are we going to see any fourth roots or sixth roots or eighth roots for that matter. So for our purposes, maybe you can just kind of think, don't take the square root of a negative. And that's it? Well, kind of. I mean, that's it for our class, or at least for this point in our class. Later on in this class, we're going to learn about logarithms. And it'll turn out that you can't take the log of 0. But because we haven't learned about logarithms yet, you shouldn't expect to see any functions that have logarithms in them, so you don't really have to worry about the fact that you can't take the log of 0. But while I'm here, I should point out that you also can't take the log of a negative number. And then you're like, oh, okay, so really there's 4 rules, but at this point in our class, there's only 2 rules. Okay, at this point in our class, there is only 2 rules. Later on in this class, we will incorporate 2 more rules, but even that is not a complete list. In fact, there's tons and tons of things that you can't do in math that lead to an undefined output. The point is just, this list is far from complete. There's lots and lots more, but for the purposes of our class, there's just 2 things you gotta worry about. When you have a function, you have to kind of analyze that function to make sure that you're not going to divide by 0. And when you have a function, you have to analyze that function to make sure you don't take the square root, technically any even root, of a negative number. And if you can do those 2 things, you can figure out the domain of a function. And if you can figure out the domain of a function, you can figure out the range of a function. And in the coming videos, I'll show you explicitly how to do all those things. But in this video, I really just wanted to give you an introduction. So at this point, if you sort of understand what the domain is, and namely how 4 is in the domain of this function, but 1 is not, and what the range is, and how 2 is in the range of this function, then you have a really good conceptual understanding of these 2 vocabulary words. And maybe from that conceptual understanding, you're able to realize that it's going to be really important to figure out what inputs might cause a function to give me an undefined output, so that I can figure out what numbers are not in the domain of a given function. And to answer that question for our class, there's just these top 2 rules that we have to deal with, at least for this point in this class. I think this is a good ending spot, so I'm going to stop this intro video here.